Very good morning, my dear friends. And in today's video, we are going to work out a problem on a square pyramid. And the question for today's video reads as a square pyramid of side of base 40 mm and axis 65 mm long rests on its base on HP with all the four sides of the base equally inclined to VP. So the dimensions of the pyramid are known, and how the object is placed on HP is also known. So we will be able to draw the front and top views, that is the projections of the square pyramid. Friends, here we will write a square in the top, that is top view. It appears as a square with sides measuring how much? 40 mm. So we'll call this as A, B, C, and D. This is the base. And if we join these corners to the apex or the vertex of the solid O, you will get the top view, and each of these side is measuring 40 mm. You can say 40 SQ or SQ 40, indicating that the dimensions of this side is 40 mm each. This is the top view, friends. Now, this is the XY line you have got. We will project all these points to the front view like this. This is point A, B and D. This is point C. So, through this, we will draw a vertical line representing the axis of the solid. Join the vertex O dash to these points of the base like this. This is point edge 1, edge 2, this is edge 3, and this is the base of the solid. And we can number these as A dash, B dash, D dash, and this is C dash. O dash and O1 dash are the center of the vertex and the base center. Friends, we will draw the development of the lateral surface of this square pyramid. We know this OC is parallel to VP, O dash C dash, or this O dash A dash represent the true length. So I mark a line here of length equal to this and say this is the true length, and this point is O. So I draw an arc here, taking O as center, O dash A dash as radius. Suppose this point is A, and on this I step off AB, BC, CD, and DA, each equal to 40 mm. So say this is 40, 40, 40, and again 40. So we will join this O to the last point here, and join this O to all these base corners, and we can number them as A, B, C, D, and A. Again, if since it is a square pyramid, you have to join these base edges AB, BC, CD, and DA. Now, friends, the question is says a honey bee starts moving from one of the corners. One of the corners means say A. It is starting from here, one of the corners, which is this point in the top view, and moves around the lateral surface of this by following the shortest route and reaches back the position. That is, it will start from here, move around this, traverse backside, and come back to the point A. So while it is traveling it is following the shortest path possible. So the shortest distance between any 2 points is this straight line connecting those 2 points. So friends, here I am going to join this A with this A. This is the shortest distance between A and A. Now friends, this is a path this B is following. It will start from A, move like this, touch this point, move further, move, and again it comes back to the same. So it will start from A, go to this B, there's OB, then to OC, then backside you have got OD, and come back to that. And we are interested in finding out what is the path traced by that B in the front and top views. Friends, now let's say it is starting from point A. So this is point 1. This is 1 in the top view, and we can take this point A as 1. 1 and 1. Next friends, we have to mark this point on OB. Friends, OB is the true length. On OB, here on OB, at this much of distance, it is reaching the edge OB. But OB is not the true length here. So I will mark this distance on this OB. That is, you have to mark the distance here on the true length, shift that to this point. Suppose you have got this point, we are moving to move that to this point. So from A, that is 1, it will move to this point. We'll call this point as 2. So 2 is on OB. I have marked point 2. From 2, it will move further and touch this OC at this point. And friends, you can see OC is the true length line, and this distance you can mark on OC. Say this is point 3 and this is point 3 on that. And friends, it is starting from A, the corner, moves up to 2, from 2 to 3, and then from 3 to 4 on that OB, that is coinciding with that. From that 4, it will come back to this position. So this is point 1 and this is point 3 I will mark. If you just draw a line from there till it touches this OC, this is going to be our point 3. So we got 1, 3. 2 and 4 will come here. How to obtain that 2 and 4, friends? Here, friends, these 2 and 4 are at the same distance from the vertex. You can see this is going to be point 2 and also point 4. 1, 2, 3. Back side is 4. From 4 it will come back to point 1. Now here, friends, we have marked 2 points. Then how to get this point 2 and 4? So from here, friends, I will just move that point 2 to this. Draw a vertical line from there. Somewhere here it will touch. Taking O as center and that point distance as radius, I am going to draw an arc on both the sides. So this is going to be point 2 on OB and 4 on OD. We got all the 4 points here. So friends, let us start from the front view. So I am going to join 1 to 2 by a straight line, 2 to 3 by a straight line, 3 to 4 coincides with 3 to 2, and from there to this. So 1, 2, 3, back to 4, from 4 to 1, the starting point. So we have marked all these, friends. So we will join all the points so obtained by straight lines. So we have got point moving from, or the B moving from 1 to 2, 2 to 3 by a straight line, 3 to 4 and 4 to 1. It will start from A, go up to 2, from 2 to 3, 3 to 4, and from 4 it will come back to the starting point. This is how the path traced by the B appears in the front view, and this is the way it moves in the top view. So friends, I hope the presentation on this problem, an application of this development of a square pyramid, was interesting. Please go through the complete video, and if you like this video, do share with your friends without fail. And in case if you have not subscribed to my channel so far, please do subscribe without fail. Have a wonderful day.